So for our second specific outcome, we actually have something that we touched on before, comparing the interaction between static electric charges with the interaction between magnetic poles and with the interaction between two masses at a distance. Well, they are fairly similar. We can get a lot of the same behavior between electric and magnetic poles because we have the two charges. So we could end up, if we have positive and negative, we could end up with closed loops, much like we have in our magnetic fields. The difference comes in when you've got repulsive ideas, because that is the key difference between gravitational field and the electromagnetic fields. The gravitational field is always attractive. So while we do get these closed loops, we actually should have it with gaps in the middle. Because if you're closer to this mass or that one, you'll be attracted to that mass, assuming they are equal. So if we have equal masses, you will always be attracted to the closer one. And that line in between, you've got sort of this invisible zero width barrier of unstable equilibrium where you have exactly the same pull in one direction as you do in the other. With the electric fields, you can't quite do that. You can have repulsion, where things will end in a gap and move out. And as you're repelled from one and the other takes over, you get these curved lines like hyperbolae. And you'll get very similar patterns if you were to take two bar magnets, turn them so that the north sides are facing each other, the south sides are distant. Again, the north poles would push things away, but then you'd have this point of unstable equilibrium. You tip it a little bit up or a little bit down, and then they push together to keep, or work together to keep pushing you up and down. And you do get these hyperbolic shaped curves here, which do eventually close back around. So we do have a number of different field lines that we can get, but they are all based on just figuring out the forces on an appropriately charged object just sitting here. Which direction does the net force push?